Sorry, students, we'll begin shortly. I'm just need to go to the bathroom quickly and I'll be back and then we will start. I'm going to start off with this question. So if you didn't do this question, you can try it out in the meantime. Okay, good evening, people. Assalamu alaikum. Welcome back to Physics Grade 10 by Inspired Teens. Apologize for the delay, but in today's lesson, we will be doing electricity, right? We're going to be continuing with electricity. However, we're going to start off doing this question. I'm not sure if it was in the last lesson or the previous lesson that I gave this to you guys to do as homework, but I just remembered and I wanted to go through it, right? I want to go through this question with you guys. Did anyone attempt it and has an answer? Does anyone have an answer? Did they attempt it now or attempt it before? It's okay if no one attempted it, that's fine. But if anyone did, just tell me what your answer is, and then we can go through it. But yeah, again, if no one attempted it, that's perfectly fine. Okay, it doesn't look like anyone attempted it, which is cool. Let's go through it, right? So how would you approach a question like this? Just by the way, remember we did, if it can load. Where was that question? I don't think we did that question, but it's fine. Remember, we did this type of question, right? Where you're transferring charge from one to another. Same with this, right? We did it in the forward way, if you want to call it that. How do you calculate new charge after contact? How do you calculate the amount of charge that was transferred? How do you calculate number of electrons transferred? Okay, converting electrons to charge and vice versa. Okay, so remember we did those formulas, right? So we're going to utilize that in our understanding. That whole part came in the exam. Which part? Which part exactly? Okay, so yeah, right. Let's have a look at this example. So this example tells us that charge A and B above were brought into contact. Okay, and thereafter separated. After contact, 2 times 10 to the 13 electrons were moved or are moved from A to B. Okay, so since the electrons were moved from A to B, can someone tell me which one is more negative, A or B? Just from that information. Electrons were moved from A to B. So which one is more negative? By the way, are you guys done with your exams? I feel like most of you are. That's why a lot of people didn't join today. Everyone is chilling. Okay, but just by the way, for those of you who are here, we are going to continue with the classes on the holidays. So we'll probably end up doing, when we finish the syllabus, we're going to do questions and that. So just like revision. So yeah. Okay, let's continue. So because the charges were transferred from A to B, okay, that means that A is more negative, okay, because the more negative one always donates. And this one is less negative. Okay, so that's important information. Just off the top of my head, I'm remembering. Remember, the more negative one has a positive, when we do get there eventually, has a positive delta Q. And the less negative one has a negative delta Q. Okay, those are just things to remember. So after contact, 2 times 10 to the 13 electrons are moved or are transferred, basically, okay, from A to B. Calculate the initial charge of A. Okay, so we are working completely backwards. They've given us the amount of electrons transferred. They want us to go all the way back to the initial charge of A, because the initial charge of B is given. Okay, so how we are going to do this? Remember, the only formula we know with electrons is what? Q is equal to N times E. N times QE. Okay, where this is charge, remember, big Q is charge, N is the amount of electrons, and QE is a constant. So if we are going to separate here, because electrons is N, electrons transferred, I don't know if it's 1R or 2R, but anyway, if we are going to substitute the electrons transferred, what charge are we going to get? If we substitute the electrons transferred, what charge are we going to get? Okay, remember we said that the charge and the electrons have to always match. So if you're going to substitute electrons transferred, you're going to get charge transferred. Okay, always keep that in mind. So I can get the charge transferred. Okay, so that's good information to get. So I'm going to remember use my formula. Okay, my formula is this, right? Q is equal to N times QE. And I'm going to substitute. Okay, so 2 times 10 to the 13 times, remember the constant, right? The constant is 1,6 times 10 to the negative 19. Okay, and we can actually substitute minus, but it doesn't matter. I'll show you why. This gives us an answer of 3,2 times 10 to the negative 6 coulombs. So just keep in mind, this is not just any Q, this is delta Q. Why is it delta Q? Why is it change in charge? Okay, because we substituted, we substituted electrons transferred, which means we got the charge transferred. Charge transferred is delta Q. Okay, so you get technically negative 3,2 times 10 to the negative 6. Isn't it negative 1? Yes, correct. Technically, you get negative 3,2 times 10 to the negative 6. But remember, we work off this information. This is crucial to us. Which one has a positive delta Q and which one has a negative delta Q? So negative delta Q would work for B. A positive delta Q would work for A. Okay, so now that we have delta Q, what other formula do we know that works with delta Q? Delta Q is equal to Q new minus Q old. Okay, am I correct? Correct. Q new, so the new charge on each, we don't know. We don't know what Q new is. Okay, but we know delta Q, and we know one of the Q olds. We know delta Q, and we know one of the Q olds. The Q old is 4 microcoulombs, right? But now when we choose, if we choose B to work with, we have to choose a negative delta Q, which works out fine. So we say negative 3,2 times 10 to the negative 6 is equal to Q new, okay, minus the Q old we're working with is 4. 4 times 10 to the negative 6. When we sort out Q new, when we arrange to leave it alone, it basically becomes 1.2, I'm pretty sure, negative 3.2 times 10 plus 4 becomes 0.8, sorry. 0.8 times 10 to the negative 6 coulombs. Okay, so this is the Q new that we've calculated. Now, what formula do we know that's involved with Q new? Ah, yes. Q new is equal to Q1 plus Q2 over 2. Okay, so now we have Q new. We have Q2. We can calculate Q1. And obviously 2 is 2. So we substitute. Q new is 0.8 times 10 to the negative 6 is equal to Q1, which is what we want to solve for, the charge of A, plus Q2. Q2 is 4 times 10 to the negative 6 divided by 2. So it becomes 1,6 minus 4. It becomes negative 2,4. Q1 is negative 2,4 times 10 to the negative 6. Okay, which is basically negative 2,4 microcoulombs. Sorry, this should be in coulombs. Okay, so that's how you solve that question. Okay, it's looks short now, but it's not really easy to understand. Okay, it's about working backwards and knowing your formulas. And that came in the exam, all of those calculations. Yeah, that would be expected for electrostatics at least. Okay, it's about knowing your formulas really well and understanding what they do. Okay, so let's move on to some electricity. Okay, I think we said we're going to discuss. Okay, I was going to give you a weird question. I remember, I'll draw it. I think we said we're going to discuss this question, right? So, let's have a look at this question. Okay. Someone tell me, okay, which connectors are in series on the circuit? Which resistors are connected in series in the circuit? Okay, maybe my question is a bit ambiguous. Which connectors, okay, are on the main circuit? Which connectors are on the main circuit? Okay, that's good, right? I'm glad you guys made that correction when I specified. So let's discuss it, right? So like maybe so those of you are confused, like why, like, okay, some of you might think like this here is series. Okay. You might think like this whole thing here is series. Okay, so let's get rid of this misconception, right? Even though it might look like the outside wire, okay, and then this is the parallel part, that's not the case, okay? Remember we said that parallel starts as soon as the circuit splits. Parallel connection starts as soon as the circuit splits. So when it gets to a point where it has two options, you have exited the series part of the circuit and you have now entered the parallel part of the circuit. So here it goes up. It has two options. It's going to go up and it's going to go down. Does it always split equally? No, but we know it splits. Okay, that's the main thing for now. We know it splits. We'll say I branch 1 and I branch 2, right? The current goes up, current goes down. So that's the main thing. So when you ask which is the like series part of the circuit or the main, what's on the main circuit, right? Remember we said the main circuit is everything but the parallel part of the circuit. So everything else, right? So when we talk about it, we say here, this here. This is the main circuit, okay? And anything that's connected here would be connected in series and to the series part of the circuit. Now, it thereafter splits into parallel. Okay, it splits here, like this. And now this red part, we call this the parallel. We'll call this the parallel part. Okay. Now, within the parallel part, okay, we can see that it initially has two branches. Okay. It initially has two branches. It splits I branch 1 and I branch 2. Okay. So its first two branches are here. Okay. And here. Because that's where it splits. Right? It splits up and it splits down. What is it powering? What is the red going into? The red is going into this. This red is going into that. Okay. So we have now, oh yeah, remember last time we ended on this. They act as one parallel combination thing. Okay, so splits up, splits down. Okay, and the red part, okay, is the first two branches, you can say. Okay, so like I've circled the boxes. Okay, it splits for that and that. That's I branch 1, I branch 2. Now, within I branch 1, let's call this, well, let's call this 1. Let's call this 2. Within that parallel branch, okay, the top parallel branch, tell me, are R2 and R3 connected in series or parallel? Within that parallel branch, R2 and R3, are they connected in series or are they connected in parallel? See, they are connected in series. Very good. Would series ever be in parallel? Would series ever be in parallel? So I think this is exactly the question you're asking right now. When you say, would series be in parallel? Yes, you can have on a parallel branch resistors connected in series. Okay, so to calculate the effective resistance of this branch, you just add these two up. Then that total, okay, you do 1 over R1 plus 1 over R2 with everything here. Okay, so parallel branch 1 up top, parallel branch 2 at the bottom. On top, we have 2 connected in series. On the parallel branch, we have 2 connected in series. Then we look at the bottom. Yes, that's what happens here, man. At the bottom, okay, it splits into this branch in red, and then it splits again, okay. You can see that it has 2 options now. It splits again. Into this. Okay. Now, tell me, R4 and R5, how are they connected? Within the parallel branch, how are they connected? In series or in parallel? On the parallel branch, how are they connected? In series or in parallel? Anyone? R4 and R5. This and this. Nobody? Parallel. Okay, very good. They connected in parallel. Okay, so within the branch, okay, don't worry, we're not going to do this question. We're just trying to understand like a really crazy example of how you can split the current and truly understanding series parallel, series on parallel, parallel on series, parallel on parallel. Like this is a crazy example. Okay, so here, right, yeah, so like I said, this is connected in parallel. So the current goes to branch 2, okay, and then it has an option to split again, up and down, okay, and then you have the 37 and the 45 ohm resistor connected in parallel. The parallel ends, and then you have the 75. Okay, so remember the effective parallel connection of these two is connected in series. Let's just say the effective parallel is 10 ohms. It's connected now in series. If we have to just get rid of the parallel and replace it with its effective resistance, it's connected in series with the 75. Right? So it's almost like you have 2 series connections on the 2 parallel branches. However, just one is in parallel, and we have to calculate its effective resistance. Okay, actually what we are going to do, however, is we're going to calculate the effective resistance of this at least. Okay, so first things first, we need to remember that our total is equal to R parallel plus R series. So for the main circuit, right, we just have 1 in series, which is this R1, that's on the main circuit, so 80. So I'm just going to say R series is equal to 80 ohms. Now R parallel is where it gets really complicated. Okay, so firstly, we are going to calculate the effective, we need to calculate the effective resistance of each branch, I branch 1 and I branch 2. So the effective resistance, remember this is connected in series. So in R series, this is equal to R, we'll just add them. So R2 plus R3. So it's 49 plus 51, which is basically 100. So that gives us 100 ohms, right? So this entire thing Okay, could like it's the same concept here, right? Like this entire thing could be replaced with one resistor that has 100 ohms. So sometimes if that's confusing you, maybe you could do that. Calculate the total resistance and just replace it with one resistor every time. Okay, so yes, that's 100 ohms. Now remember, we need to add it to this. Now, how in the blue moon do we do that? Okay, we need to add it to those resistors. So that's simple, because remember I said if you break it down, right? This guy is like one resistor. So let's calculate its effective resistance. Now this is a parallel connection. R4 and R5 are in parallel. So you're going to say 1 over R parallel is equal to 1 over 37 plus 1 over 45. Okay, let's do the calculation. Just 1 second. Second, sorry. Okay, so yes, so 1 over RP. So I'm going to do this calculation. So you can just put in your calculator 1 over 37 plus 1 over 45, right? And this is going to give me an answer of 1 over RP is equal to 82 over 1665. Now, if I want to get RP, I flip it, RP over 1, it would be equal to 1665 over 82, all right? Remember that. So I put in my calculator. I'm going to get an answer of that parallel connection having an effective resistance of 2,30 ohms. So sorry, 20,3. So like I said, again, it's like we can replace this guy with one resistor, okay, that just has 20,3 ohms. So now that we do that, if we want the resistance of this branch, we can just add these two because the 20,3 ohms and the 75 ohms are connected in series. We never did the calculation class in class, but I'm sure it'll help a lot. Yeah, I know. You see, the thing is, like, I know for a fact, like most teachers will probably do calculations just because you see, if you look at the government's plan for the syllabus, the calculations are only supposed to be next year. You guys are so only supposed to be learning the easy calculations like these ones. But it's like pointless. Like, why are we just going to sit and just learn this part of electricity? So I decided to just start calculations one time. And going into it, obviously now when you started in school, it's going to be a lot. It's going to be helpful as well. And provided that most of you are probably done with your exams, it shouldn't be an issue, I think. Okay. So again, it's like we replaced that entire thing with 120,3 ohm resistor. So now if you want to calculate the this blue part, okay, let me use blue. If you want to calculate the effective resistance of this blue part, let's change this to blue as well. Okay, let's change this to blue. Okay, we can see that it's also connected in series. So our our series is equal to just like it's just R1 plus R2. It's actually, I don't know, R6. I'm gonna say plus R parallel, because that's what it is. So that's equal to 75 plus 20,3. Okay, and this is equal to 95,3 ohms. So this part here is 93,3 ohms. Okay, so the effective resistance of this is 100 ohms. The effective resistance of this is 95,3 ohms. Now tell me, right, these two blue boxes, I basically, again, it's literally like I can replace this entire thing, okay, with 100 ohms, and this entire thing with 95,3 ohms. right? But now someone tell me, how are these two connected in? The 100 ohms and the 95.3 ohms, how are they connected in? Parallel or series? Very good, right? Parallel, they connected in parallel. Okay, so please, yeah, how do we calculate parallel? So finally, right, for all of this, I'm going to do a calculation. I'm gonna put another copy of the circuit unedited without all these colors. Okay, so this is gonna be 1 over RP is equal to 1 over 100 plus 1 over 95.3. Okay, so I've put in my calculator 1 over 100 plus 1 over 95.3, and that gives me, I'll put the fractional value 1953 over 95300, and I flip it. Okay, so RP over 1 is equal to 95300 over 1953. Then I get RP as, if I say 1 over ounce, I get 48.8 ohms. So that means that the entirety of this parallel branch is 48, has an effective resistance of 48.8 ohms. Okay, and then we say our parallel, okay, we already calculated it. Our parallel is equal to 48.8 ohms. So our total is equal to our parallel, which is 48.8 ohms, plus our series, which is 80. Our total is 128.80 ohms. Okay, hope that makes, oops. Okay, I hope that makes sense. You okay? Oh, we have a physics class, we write physics on Friday. Okay, cool. Are you guys writing on calculations in electricity or not? Okay, I'm gonna attach a question, yeah? Let me just put it here as well. Okay. And let's do just this weird question that is maybe weird, maybe it's not weird. Okay. R1, R2. Do we do rounding off decimals or put the exact? So you always, your final answer, you're always going to have to round off to 2 decimal places. So you want to try not to round off in the middle of your calculations. You always want to try and round off in the end, right at the end. Okay, so sort of keep that answer in your calculator and try and work with it. Use ANS, use the ANS feature that carries over your previous answer to do more calculations going further, and then round off in the end. Okay, R1, R2. Connected in series, parallel. Which one is series? Which one is parallel? Or how are they connected? Explain to me, somebody. Okay, parallel. Okay, very good, right? It is parallel. So you might think like, okay, maybe one is series or what, but the easiest way, like I keep saying, follow your current. Okay, if I follow my current here, okay, because remember positive to negative terminal, immediately it splits. Immediately it splits, as you can see. Immediately it splits. Okay. Then it comes back. Okay, so parallel connection. Okay, and it enters the main circuit again. So what's weird about this question is that the only part that's the main circuit is in green. It's a very small part. So if you needed to connect anything in series, you'd have to connect it here somewhere. Okay, so let's go ahead and do a question. Okay, this is a summary, by the way. I don't know if I went through it, but you can go through it, right? It's a summary of a few things, right? You just go through it, current, units, the equations, the meaning, and then some diagrams explaining it, like series and circuit, series and circuits in series and parallel and combination. Let's have a look at this. Consider the circuit diagram with 3 resistors as given below. Okay, so tell me which ones are parallel, which ones are series? Which ones are parallel, which ones are series? Which ones are parallel and which ones are series? Two ohm and 5 ohm parallel, correct, and 3 ohm series. Okay, I put a poll up to see, answer the question. I put a poll up. I don't know if you guys had received it, but yeah, just select the right option. You can try the poll feature, I guess. Use the poll to tell me the answer. Basically, just select A, B, or C, whatever you think the answer is. Okay, let's go through it. All right. Consider the circuit diagram with 3 resistors given below. How are the readings on voltmeters V1, V2, and V3 compare with each other? So V1 is measuring the total voltage, right? The voltage of the entire circuit. Because it's measuring, it's connected around the battery. V2 is measuring the voltage of series, right? Of the series connection. And then V3 is actually measuring the voltage of parallel. Okay. Technically, it's actually not reading the entire parallel. It is reading parallel, but it's reading the voltage of 5 ohm resistor. Okay, that's technically what it's reading because it's on the circuit for the 5 ohm resistor. If I have to redraw this, I could literally redraw it like this. 5 ohm resistor, 2 ohm resistor, voltmeter. V3 could also be drawn like this. Okay, the fact that it's just drawn on the edges doesn't mean anything because the 5's wire is this. All of this. That's part of 5's wiring. Okay, so V3 could be drawn exactly like that. Okay, so let us have a look, right? So what are the options? They say, how will the readings on voltmeter? Okay, V1 is equal to V2 is equal to V3. That's definitely not true because V1 is total volts. And then remember, volts splits in series. So volts will give some to the series and then some to the parallel. So by the way, this 5 ohm volts, this V3 is going to give the volts of the 5 ohm and the 2 ohm. If there's a V4 here, V4 would be equal to V3. Why? Because they connected in parallel and voltage doesn't split in parallel. Okay. What about B? V1 is greater than V2 plus V3. So V2 is the total of V series. Fair enough. Okay. V2 is the total of V series. What about V3? V3 is also the total of V parallel because this one uses 5 ohms. Oh, sorry. This one uses V3 and that one uses V3. So the correct thing should be V parallel plus V series. So V3, when you add V3 and V2, you should get V total. Because again, this is the total volts of the parallel. Okay, it doesn't split, it gives it equally, 10 volts, whatever the voltage is. And the series takes some. And when you add those two, you should get total volts. So therefore, D. Okay, C out as well. Thank you for those who participated. Let's have a look at this question. Question 9. In the circuit below, the connecting wires and the battery have negligible resistance. Okay, they always ignore resistance, right? Sorry, yeah, YouTube. The poll was on Zoom. I'm not sure if I can create a poll on YouTube, but the poll was on Zoom. Okay, so in the circuit, the connecting, okay, cool. So again, we have a very common type of circuit here. Tell me what's connected in series, what's connected in parallel. What's connected in series, what's connected in parallel. Okay, correct. So the 25, 24, and 8 ohm are connected in parallel. Okay, and the 2 ohm is connected in series. Okay, so let's okay. So when you say 24 volt parallel, we don't really care about the voltmeters and we don't remember the voltmeters negligible resistance, so we don't even consider it part of the circuit. We just think of the voltmeters, they measure current. That's it. They don't affect the circuit in any way, so we don't even care if they're connected parallel, series. We do know, and we have to know how they're connected in parallel and how they're connected in series, but they don't ever affect the calculations, so we never even consider them if I'm asking what's connected in parallel. Okay, the voltmeter is definitely always connected in parallel. So we can follow our circuit, right, from positive. We don't have two options. We pass through the 2 ohm resistor. So we know for a fact that definitely there's 2 ohm resistors in series. Then we get here and now we have 2 options. And now we should know, okay, this is the parallel part. Then it goes through 24 as well as 8 and meets up again to form the main circuit and goes back into the battery. Okay. So red part, main circuit, green part, parallel combination. Let's see what they're asking us. They say define the term resistance. It is the ratio of potential difference across a resistor to the current in a resistor. Right, remember we defined it a bit earlier. Ratio of the potential difference across the resistor and the current in that resistor. Okay, calculate the equivalent resistance. Okay, we're going to end a bit late. So for those of you who want to try this, I'm going to give you like 1 or 2 minutes to try this question. 9.2.1, equivalent resistance of the resistors connected in parallel. Calculate the equivalent resistance of the resistors connected in parallel. You have like 2 minutes, and then I'll do it quickly as well. What's the question? The question is 9.2.1. Also, if you use for 2 resistors, if you use that formula, R parallel is equal to R1 times R2 over R1 plus R2, that's also perfectly fine. If you thought that formula. Okay, so let me do it myself. Sorry if you're still busy. 9.2.1, right? Calculate the effective resistance of the parallel connections. Now, we can see that the resistors have resistance of 24 ohms and 8 ohms in parallel. 24 and 8. Now, remember, how do you calculate effective resistance in parallel? You say 1 over Rp is equal to 1 over R1 plus 1 over R2. So 1 over Rp is therefore equal to 1 over 24 plus 1 over 8. 1 over 24 plus 1 over 8, you get 1 over 6. So 1 over Rp is equal to 1 over 6. So Rp, you want to flip it because you don't want 1 over Rp, you want Rp. So Rp over 1 is equal to 6 over 1. So therefore, Rp is equal to 6 ohms. All right, so the effective parallel resistance of the parallel connection is 6 ohms. Calculate the total resistance of the circuit, just to remember that R total is equal to R parallel plus R series. Okay. Okay, so R total is equal to R parallel plus R series. 9.2.2. R total is equal to R parallel plus R series. Now, R parallel we calculated. Okay, R parallel is equal to 6 ohms. R series, can we calculate it? Okay, there's no need to calculate R series. The reason being is because there's only one resistor in R series. If there was 2, however, we just add them up. Okay, if there were 2 resistors in series, we just add them up because that's how you calculate the resistance in series. You just add them up. There's no need to do 1 over R1 and 1 over R2. You just add them up. So this is just 2 ohms. So therefore, R total is going to be equal to 6 plus 2. R total is 8 ohms. A total of 8 ohms. Okay. Okay, that's it. They didn't ask nothing else. Really? Really? Okay, we might need to calculate current for another question. Let's see. They say when the switch is closed, okay, so the switch is closed, the voltmeter connected across the 2 ohm resistor measures 6 volts. Determine the potential difference across the parallel combination. So this here measures 6 volts. Okay, they say the voltmeter connected across the 2 ohm resistor measures 6 volts. What would okay, then they say determine the potential difference across the parallel combination. Anyone, what would it be? If the series circuit is 6 volts, what would the parallel circuit be? Remember, it splits in series, okay, firstly. And remember, we said we treat the entire parallel branch like one big series block. So it's like one big series block that has an effective resistance of 6. It's an effective resistance of 6 ohms, right? So, sorry, just give me 1 second. That's tragic. Apologize. Let me restart what I was saying. So I was saying, okay, that this entire thing is like a series connection. Okay, it's like a series connection. The 6 ohms is like a series connection because the effective resistance of the parallel circuit is 6 ohms, right? So I could redraw this entire circuit with this, the 2 ohms that's currently in series, okay, and the parallel connection, which I could just replace with 1 6 ohm resistance connected in series as well. Now, if the total is 24 volts across the battery, this uses 6 volts. Remember that voltage splits in series. So what would this read? What would the 6 ohm read? Now can we answer the question? What would the 6 ohm resistor, what voltage reading would it have? Keeping in mind that voltage splits in series. Eight. No, not 8. No. I'm not talking about, don't worry about the split. I've replaced that entire parallel thing with just 6 ohms. That's it for now. Okay, not 16, 18, 18 volts. Why 18 volts? Because it's 24 minus 6, which is 18. Because V series, if you remember, is equal to V1 plus V2 plus V3 or whatever, so on. That's how you calculate the voltage that series uses. And this new circuit that we've drawn is basically only series. So it splits it. So if this one gets 6, that one gets the rest of it because there's no one else to give. So if this gets 6, that gets 18. It splits it. Okay. So therefore it gets 18. Determine the potential difference across the parallel connection, 18 volts. Okay. Okay, so let's end it there. And then next week, when we continue, we'll finish this last question and then do another question. And then maybe I'll just take a vote of like what questions you guys want to do on the WhatsApp group. And then you guys can let me know what revision questions you guys would like to do. And we can start off with those. We'll obviously do all, but I'll start off with the most popular requests and then we'll take it from there. Okay, so I hope this makes sense. Please, electricity is one of those sections that it really can get confusing. And sometimes it takes repetition and practice to get it. And finally, it will click. So even if you need to rewatch the videos or whatever, same thing you want to say because I have a term test on Friday. Good luck, firstly. Secondly, yeah, look, you should just sit with your work. Okay, practice papers. What I'll do today is I'm gonna let me make a note. I'm gonna put the past papers, a link somewhere in the group description. Many of you don't know, have access to the website with past papers. Link past papers in the group. Okay, maybe many of you, like I said, don't use past paper website. So go do questions. You know, once you do questions, you'll know what you don't understand. You'll know what you need to work on. Just 1 second, let me just message. Okay, you'll know what you need to work on. Okay, so then practice it. And then if you're starting with a certain section, try and go through the videos again. Go through those questions that I've done. If you're still struggling with a certain question or confused about something, message me and I will try my best to help you. So yeah, that's my advice. You just need to practice. And like I said, you'll know exactly what you need to work on because you'll be getting those questions wrong, or you'll be struggling with those questions or whatever it is. And then you take it from there, right? Yeah, just do past paper questions, maybe do some questions from your book. Go through the notes again. If you need to watch the videos on certain topics again, then do so. When I was starting chemistry next term, after we do maybe some revision, the first thing we do next term is chemistry, state of matter and kinetic molecular theory, periodic table, chemical bonding, stoichiometry, quantitative aspects of chemical change, and so on. Next term is very chemistry heavy. But yeah, okay, cool. So let's end it there. If you guys have any questions, you can ask it now while we are, yes. But yeah, thank you guys so much for joining. All the best for your guys' week. Okay, good luck for your tests if you are writing. Enjoy your holiday if you're done with exams and you're on holiday. And yeah, please note we will be continuing with these classes in the holiday, so please do attend. Okay, don't fall behind. We'll be doing revision. It's important to revise. It's just 1 hour a week. That's it. The rest of the week you can chill. But yeah, thank you guys again so much for joining. Jazakallah khair. Assalamu alaikum.